and welcome to this presentation on Python's garbage collection mechanism. Today, we'll explore how Python manages memory and automatically removes unused objects. Garbage collection is crucial for preventing memory leaks and improving the performance of your application. Before we get into Python's garbage collection, let's first look at reference counting. Every object in Python has a reference counter, which tracks how many variables are pointing to that object in memory. For example, when I create variable z and assign it to the value 5, Python creates an object in memory to store that value. The value of this object is 5, and the reference counter is set to 1. It's clear? Now, if I create another variable, say a, and assign it the same value as z, Python doesn't create a new object. Instead, it points a to the same object and the reference count for that object increases to 2. Similarly, if I assign b equals z, the reference count goes up to 3. Because now, 3 variables z, a, and b are all pointing to the same object. This helps Python manage memory efficiently by avoiding the creation of unnecessary duplicates. Now that we have covered the basics of reference counting, let's move to another scenario where it can run into issues reference cycles. A reference cycle happens when two or more objects refer to each other, stopping their reference counts from reaching 0. For example, imagine two Python objects, node1 refers to node2 and node2 refers to node1. This creates a circular reference. Even if there are no other reference to this object in the code, they will still stay in memory because they can't be freed. This shows a common challenge in managing memory, especially in programming languages that don't automatically handle cycles in reference. Now, let's explain our topic, garbage collection. So what is garbage collection? Think of it as an automatic memory management technique. Its purpose is to detect and remove objects that are no longer needed by the program. Instead of requiring the programmer to manually free memory, garbage collection identifies and frees memory that can be reclaimed, ensuring efficient memory use and preventing memory leaks. Let's take a look at the different techniques of garbage collection. First up, we have mark and sweep. Next is reference counting. Then we have generational garbage collection. Finally, there is tracing garbage collection. I will dive into each of these techniques shortly. The mark and sweep algorithm is one of the simplest types of garbage collection. It works in 2 steps. First, it marks all objects that can be reached from a set of root objects, and then it sweeps through memory to free up all the unmarked objects. This process helps to remove objects that are no longer needed. However, a downside is that the program has to pause during these steps, which can cause delays in execution. Now, let's talk about generational garbage collection, a smart way to manage memory in programs. So, what exactly is generational GC? It's a technique that organizes objects based on their age. We have 2K generations. Generations young, this is where we previously talked about reference counting, which is an effective way to monitor how many references point to an object. When this count drops to 0, the object can be deallocated. However, as we discussed earlier, reference counting has difficulties handling objects that reference each other, leading to reference cycles. This is where more sophisticated garbage collection techniques such as tracing GC become important. What is tracing GC? Tracing GC is memory management technique used in Python to track objects in memory and remove those are not longer needed. This helps prevent memory leaks. It ensures only objects still being used, reachable, stay in memory, while unused ones are cleared. So, how does a tracing GC work? It uses a process called mark and sweep. First, it marks all objects that can still be reached from a set of root objects. Then, it goes through memory and removes the objects that were not marked, which means they are unreachable. So, what is the difference between tracing GC and mark and sweep? Mark and sweep is just one type of tracing GC. Tracing GC includes several methods that check which objects are still reachable by tracing a reference between them. Okay, it's clear? Now that we have covered each garbage collection method, let's compare them quickly. First, mark and sweep is a classic technique that marks reachable objects and removes the rest. It's simple, but can pause program execution. Next, a reference counting. Use it in Python, CPython, freeze memory as soon as objects are in referenced but struggles with circular references. That's where tracing GC comes in, identifying unreachable cycles by scanning the object graph through it may cause brief pauses. Finally, generational GC. Generational GC focuses on optimizing for short-lived objects while reducing the need for frequent full memory scans. In Python, CPython combines reference counting for immediate management with generational GC for longer-lasting objects and cycles, balancing speed and thoroughness. Let's explore some best practices in Python that can help us with more efficient and memory-friendly code. This table highlights the most important tips for optimizing how we use memory in our Python programs. Use built-in types efficiently. It's important to favor Python's built-in data types like lists, dictionaries, and sets because they are already optimized for performance and memory usage. Avoid circular references. We need to be careful with the objects that reference each other. This can lead to memory leaks, which mean Python cannot free memory correctly. Leverage context managers by using with statements, especially for resource like files or database. We make sure that memory is released as soon as we are done with the resource. The next, deliberately delete unused objects. It's a good habit to manually delete objects we don't need anymore, especially large ones. This helps free up memory sooner. It is good. Also, we can use module GC, use GC collect when necessary. Sometimes manually triggering garbage collection help us recover memory from objects that are no longer being used but are still referenced, and we already saw that. Profile memory usage. The tools like memory profiler or trace malloc are very helpful really for monitoring how much memory our program is using, and also this helps identify and fix memory related problems. Also use weak references with the weak refs. We have a module weak refs. We can avoid memory leaks, especially in complex object relationship where objects keep each other alive. Also, limit the lifespan of large objects. We should keep in large data structure in memory for too long can cause overheat. It's better to remove them when they are no longer needed. Also, optimize loops. Finally, we should avoid creating new objects in loops when we can. This help prevent excessive memory use and improves the performance. I wish it's clear for you, and maybe for next video I will share more best practices to manage memory. Don't forget to apply garbage collection not just to your code but to your life as well. By managing your space, you create a sense of freedom and clarity. Remember, code with style and shine with glam. See you soon!